Hokkaido Research Organization, or Dosoken, was established in 2010 as a public testing and research institute that contributes to studies on living conditions and industry in Hokkaido. We work towards building a Hokkaido with dreams for the future based on our motto, "Our research realizes new dreams for Hokkaido." Dosoken has 21 research institutes and stations with about 1,000 employees. There are 5 departments working for agriculture, fishing, forestry, industry, and architecture. The Building Research Department consists of Northern Regional Building Research Institute and Building Performance Testing Center, and is in charge of architecture and community design. It is the only prefectural testing and research institute in this field in Japan. The Building Research Department was established in Sapporo in 1955 to improve quality of life in Hokkaido through researching the planning and development of cities and housing in cold regions. We moved to Asahikawa in 2002. The Northern Regional Building Research Institute, or Hokusoken, conducts research for both Hokkaido Prefecture and private companies funded by the government and various foundations. Our research here can be divided into 4 main fields. Here is an overview of our recent efforts. Management of communities and housing. We are working on the research and implementation of regional management through new mutual assistance in communities facing declining population, falling birth rate, and aging population. For example, we are seeking a way to build systems to maintain local water infrastructures in cooperation with the local government, residents, and high school students. We are also examining the feasibility of transportation operated by collaboration between local governments, residents, and businesses in regions where public transportation and local logistics have become difficult to sustain. In the field of housing, we cooperate with the government in policymaking and developing technology to popularize Northern-style housing as housing standard in Hokkaido. We are also working on enhancing to utilize vacant houses and preventing houses from being vacant and left. Building safe communities. To promote disaster preparedness for earthquakes in Hokkaido, we are researching scenario earthquake and damage estimation, as well as verifying the effectiveness of various disaster mitigation strategies. We measure actual evacuation speeds during the snowy season with evacuation drills to improve accuracy of damage estimates. And we assist in creating municipal tsunami evacuation plans as well as the construction of tsunami evacuation buildings. During the 2018 Hokkaido Eastern Iburi earthquake, we collaborated with local governments to conduct rapid safety assessment of buildings and provided technical guidance on temporary emergency housing suitable for cold regions. Architectural environments and energy saving. We are developing technology of energy saving utilizing renewable energy for government buildings and schools. In collaboration with research institutes within Dosoken, we propose use of new technologies in environmental control to achieve thermal environments that enhance the productivity of greenhouses and other production facilities. In response to Hokkaido's high demand for heat in the winter, we engage in research for energy conservation and utilization of renewable energy in the region. Good quality building stock. In order to prolong the health of building, we developed the rational, labor-saving inspection and evaluation methods to support municipalities in building stock management. In order to increase demand for Hokkaido timber, we have developed and commercialized the fire prevention wood wall, which allows the use of wood for exterior walls at a low cost while meeting Hokkaido's high specifications for insulation. In addition to commissioned experiments, evaluation of architectural performance, and structural calculation conformity judgment, the Building Performance Testing Center conducts fundamental research aimed at improving measurement and analysis techniques. For commissioned experiments, we provide tests as shown here. Usage of our facilities allows us to provide development of products and technologies for various companies and organizations. This is a designated evaluation of architectural performance agency appointed by the Ministry of Land, Infrastructure, Transport, and Tourism for fireproof construction and development of fireproof materials. As the only agency of its kind in Hokkaido, it provides evaluation of architectural performance based on the Building Standards Act. As an institution designated by the Governor of Hokkaido, we conduct structural calculation conformity judgment services for buildings that require advanced calculations. We also have an office in Sapporo working in this division. We report the results of our research and our technical findings through various methods. Every year, we hold a seminar for local administrative staff on community development. This is an opportunity for staff from Hokkaido municipalities and Dosoken to work together to develop strategies for managing communities while thinking ahead decades into the future. In addition, we promote collaboration between industry, government, and academia by providing designs for public buildings, assisting municipalities with administrative issues, and conducting joint research with private companies and universities to address social needs. As an organization with close ties to Hokkaido's citizens, businesses, and municipalities, we disseminate research results by holding seminars and lectures, as well as reporting information through our website, social media accounts, and various other means. We also offer public tours of our research facilities, technical consultations, and dispatched lecturers, so please feel free to contact us. The following is an overview of the facilities used for most of our testing. In our wind and snow environment simulation lab, the effects of wind and snow on buildings are tested in a wind tunnel. To assist architects with blueprints based on adapting to environmental factors, we propose structural forms and layouts that prevent snow cover, snow accumulation, and snow drifts. Our structural strength and durability lab is equipped with 4 types of machines for testing durability, including a full-scale lateral load tester to measure the strength of buildings and materials against things like seismic forces. At our seismic resistance lab, structures are shaken in simulations using data from actual seismic activity. Our twin chamber with temperature and humidity control lab has windows and walls placed between 2 rooms with a temperature difference to test the performance of insulation in a simulated barrier between indoor and outdoor environments. Our air and water tightness testing lab uses specialized equipment to conduct tests on the damaging effects of wind and rain on windows and walls. This building was designed and constructed in 2002 using the results of our research on technologies to reduce environmental impact. Natural ventilation. We have reduced energy consumption by introducing a ventilation system that harnesses forces of nature, such as wind and air currents caused by temperature differentials between upper and lower levels of an atrium. Efficiency of natural light. In addition to diffusing and reflecting direct sunlight, natural light from an atrium is also utilized to significantly reduce energy consumption for lighting the offices. Through these methods and various other strategies, we have reduced energy consumption by more than 40% of a typical office building. We continually review such operational methods to further reduce energy consumption. The Dosokin Building Research Department has been conducting research and disseminating findings in the fields of architecture, housing, and community design in snowy and cold regions to provide support for improved living conditions and the development of construction-related industries in Hokkaido. Dosokin pledges to continue contributing to the creation of a sustainable Hokkaido.